Circuit protection for IEEE 1394 interfaces. IEEE 1394 interface technical details. Cable structure. 6-core cable. Includes 2 power cables and 4 signal cables. Power cord. Provides power to standby devices or low-power peripherals on the bus. Signal lines. Divided into 2 pairs. One pair transmits data and the other pair transmits clock signals. Outer shielding layer. Reduces electromagnetic interference. Cable function. Connect different devices. Enable high-speed data transmission and power supply. Supports synchronous data transfer. Can be connected to a variety of devices, such as PCs, cameras, video recorders, printers, scanners, etc. Data transfer rate. The maximum data transfer rate of the IEEE 1394 interface can reach 1,600 megabits per second, 1394B standard, which is much faster than USB 2.0. It can transfer large amounts of data, such as a high-definition movie or a large number of photos, in a very short time. Signal system. The IEEE 1394 interface uses a low-voltage differential signaling system, which means it can transmit signals at low voltage while maintaining high transmission speeds. This signaling system can effectively reduce electromagnetic interference and improve transmission reliability. Performance optimization measures. Reduce cable length to reduce signal transmission delay and attenuation. Use high-quality connectors and plugs to ensure good contact and transmission quality. The importance of suppressor capacitance and its minimization. Suppressor capacitors are critical in reducing signal line noise and interference in high-speed data transmission systems. Excessive suppressor capacitance will increase signal line delay and attenuation, affecting transmission performance. In the IEEE 1394 interface, the appropriate suppressor capacitor needs to be selected to balance noise suppression and transmission performance. ESD protection and solutions. The impact of ESD, electrostatic discharge, on electronic equipment. ESD may cause damage to components and circuits of electronic equipment, such as breakdown of insulation layers, burned components, etc. Therefore, ESD protection is crucial for the IEEE 1394 interface. Characteristics of the IEEE 1394 interface. The IEEE 1394 interface is a high-speed serial interface that supports hot plugging and synchronous data transmission. Therefore, the requirements for ESD protection are higher and more effective protection measures need to be taken. Protect equipment from damage. Through ESD protection, the damage caused by ESD to equipment can be effectively prevented or reduced, and the reliability and stability of the equipment can be improved. At the same time, users can also be protected from data loss or device damage. The role of multilayer varistor. Nonlinear resistor devices absorb transient overvoltage and overcurrent on the power bus to protect equipment from damage. The role of PTC. The positive temperature coefficient thermistor provides resettable overcurrent protection, automatically cuts off the circuit and restores the conductive state, ensuring the safety of the equipment and returning to normal operation. Choose from a variety of ESD protection devices. In addition to multilayer varistors and PTCs, TVS diodes, gas discharge tubes, etc. are also effective choices. They absorb and disperse ESD pulses, protecting equipment from damage. Consider IEEE 1394 interface characteristics. When selecting ESD protection solutions and devices, the low-voltage differential signaling system and hot swappable and synchronous data transmission characteristics of the interface should be taken into consideration. Make sure the selected ESD protection scheme does not interfere with data transmission. IEEE 1394 uses a low-voltage differential signaling system, operating voltage between 1.20 V and 2.00 V, with a maximum data transfer rate of 400 megabits per second, 1394A, to 1,600 megabits per second, 1394B. When reaching this data rate range, the capacitance of the suppressor should be minimized. Signal lines that need to be protected from ESD include TPA+, TPA-, TPB+, and TPB-. The 30 VDC power bus also needs to be protected from ESD and overcurrent. Solution description. Multi-layer varistors are used on the power bus to protect it from ESD, while a PTC is used to provide resettable overcurrent protection.
Supporting solution.
In addition to the above suggestions, the Yint product portfolio also offers other solutions. For example, a leaded PTC can be used instead of an SMD-type product, or a TVS diode can be used instead of an MLV. IEC 61000-4-2 is the most suitable standard specification for this interface. This test demonstrates that the end product is not susceptible to ESD hazards. Related standards and tests. Protection requirements of the IEC 61000-4-2 standard for IEEE 1394 interfaces. The IEC 61000-4-2 standard stipulates that equipment should be able to withstand a certain level of electrostatic discharge, ESD, attacks to ensure that the equipment will not be damaged or damaged by ESD during normal use. Performance degrades. For the IEEE 1394 interface, this standard also applies. The impact of the IEC 61000-4-2 standard on equipment performance. Since ESD attacks may cause various equipment failures, such as data loss, communication interruption, etc., the IEC 61000-4-2 standard requires that equipment should have certain ESD protection capabilities. At the same time, the standard also stipulates that equipment should be able to continue to operate normally after being attacked by ESD without permanent damage. The impact of the IEC 61000-4-2 standard on equipment reliability. Equipment reliability is one of the important indicators for evaluating equipment performance. The IEC 61000-4-2 standard stipulates that equipment should be able to withstand a certain level of ESD attacks, which helps to improve the reliability of the equipment and enable it to work stably in various environments. The significance of ESD testing. Evaluate the sensitivity and tolerance of equipment to electrostatic discharge, detect potential problems and their impact on equipment performance, and verify whether the equipment's protective mechanisms are effective. ESD testing methods. It includes two test methods, contact discharge and air discharge, to simulate electrostatic discharge attack situations and detect the tolerance of the equipment and the effectiveness of the protection mechanism. ESD testing standards. Follow international standards such as ISO 1065-2 and IEC 61000-4-2 to ensure the accuracy and comparability of test methods, conditions, grades, and judgment criteria. High-speed data transfer. The IEEE 1394 interface supports high-speed data transmission, and its data transmission rate can reach 400 megabits per second, 1394A, and 1,600 megabits per second, 1394B. This allows it to be widely used in application scenarios that require high-speed data transmission, such as audio, video, and image transmission. Extensive device support. The IEEE 1394 interface can connect to multiple different devices, including PCs, cameras, video recorders, printers, scanners, etc. This allows it to be widely used for high-speed data transmission and synchronization control between various devices. Strong compatibility. The IEEE 1394 interface has good compatibility and can easily connect devices of different brands and models. This makes it widely used in professional equipment and consumer electronics. Expansion of application fields. With the advancement of technology and the diversification of people's needs, the application fields of the IEEE 1394 interface will continue to expand. In the future, it will be widely used in smart home, smart medical, Internet of Things, and other fields. Integration with artificial intelligence. The continuous development of artificial intelligence technology allows the IEEE 1394 interface to be combined with artificial intelligence technology to achieve smarter and more efficient data transmission and control. This will further improve the application range and performance of the IEEE 1394 interface. Connection to IoT. The continuous development of IoT technology allows the IEEE 1394 interface to be combined with IoT technology to achieve faster and more stable data transmission and synchronous control between devices. This will further improve the application range and performance of the IEEE 1394 interface.